Welcome to the algebra section of the S.A.T. program. This is solving absolute value equations and inequalities. The name seems a bit long, but it's really not that hard. All it is there's an expression like this, for example, inside of absolute value bars, and then equals a constant. And so all you have to do, it doesn't always have to be equals either. It could be any of the inequality symbols as well. So all you have to do is simplify for x. And I will show you how to do that now. Now here we have an equation. And so there are two different ways of doing this. Well, actually, first let me mention there's two different steps to this. The first step in this one is already done. But let's say, like, out here there was plus 5. What you would do, first you would want to get rid of that plus 5. But since there's no plus 5, we'll just erase that. Okay, so here, all you'd have to do is, there's two different things for this. So you just branch out like this. There's two different things. First, there's the positive solution, which is exactly how it says it, like nothing changes. And for this one, just minus 15, crosses it out, minus 15 equals negative 3, and then divided by 3, crosses it out, divided by 3, equals negative 1. So x equals negative 1. And so that would be the positive solution for this equation. Now the negative solution is basically you take everything that's in this expression right here and multiply it by negative 1. So it would be negative 15 minus 3x equals 12. Now the constant that's outside of the expression does not change according to this, so you don't have to change the 12. So now you do plus 15, you get 27, and then divided by negative 3, crosses it out, divided by negative 3, and you get negative 9 equals x. And so that would be the negative solution for this equation. Now I'm going to pass it off to Ben so he can...
Hello, this is Ben, and welcome to the second example problem for our 6.4 algebra section. So here we have an inequality, as you can see at the top, and for this one we have a different step that we didn't have last time. So what we have to do is we have to get rid of this negative 5 in absolute value bars. So what you would do is you would change this into a positive 5, but then it would be negative 5 because of the minus here. So you would have to add 5 to both sides. So then that would get you 13 greater than 2x minus 10. So that would be your overall inequality that you'll use to make the two examples that we have. So what we have to do is our positive answer will be 2x minus 10 greater than 13. So nothing changes. So what we have to do here is we have to add 10. So then you would have 23, 2x, divide both sides by 2, and you would have x is greater than 11.5. And then over here you would have the exact opposite on either side, whichever you choose. So it would be 2x minus 10 is less than negative 13. So here I did pretty much the exact opposite side of what Danny did, and I changed the less than sign, or the greater than sign, into a less than sign, and then I changed the 13 to a negative 13 instead of flipping everything on the other side. So now you would add 10, and then you would have negative 3 less than 2x, divide both sides by 2, and you would have negative 1.5. So then that would be x is less than negative 1.5. So the way that you would graph this is that you would have, this would be an OR problem, I believe. So you would have 1 and 1/2 over here. That would be negative. And then over here you would have 11.5. And then since it is greater than 11.5, you would shade it in over here and then put an arrow. And then you would shade it in over here and put an arrow for that. And that's how you do this example. And I'm going to hand it over to Danny.
Hey, this is Danny, and this is the next example. The problem is 9 is less than or equal to 5x minus 20 in absolute value bars plus 5 plus negative 5. Both of those are in absolute value bars. Alright, so first we start with the extra part that's over here, since it isn't part of the expression. So what you want to do is, since they're single values in the absolute value bars, they're automatically positive. So it would make it plus 5 plus 5. So that would be minus 10 to get rid of both of those at the same time. So we do minus 10 on both sides, and we get negative 1. Now, the problem that we're left with is negative 1 is less than 5x minus 20 in absolute value bars. Now, with this, you split it up into two different problems like we've done before. So the positive one and then the negative one. The positive one, nothing changes, so it's still negative 1 is less than or equal to 5x minus 20. Just this time there's no absolute value bars. So then plus 20 on both sides equals 19 divided by 5 equals 3 4/5. So 3 4/5 is less than or equal to x. Now, the negative one would be like this. Everything is reversed that is inside of the absolute value bars right here. So it would be negative 1 is less than or equal to negative 5x plus 20. Now, first you want to get rid of the 20, so minus 20 on both sides, and you get negative 21. Then, divided by negative 5 gets you a positive 4 1/5, because since both of the numbers in the fractions are negative, then it automatically switches to positive. And then since we divided by a negative with the negative 5 right here, this would flip, so the 4 1/5 is actually greater than or equal to x. And now to graph that, as you can see up here, it's the same exact thing, except both of them are flipped backwards so that the x is on the left side. And so now what you do here is you want to graph both of them at the same time, since it's from the same inequality. So first, let's start with 3 4/5. And you got to put that on there. And since it can be equal to right here, you got to make a full dot on the line, and then go over to 4 1/5. It could be equal to also, so you got to make a full dot on the line. Then, since here x is greater than 3 1/4, or 3 4/5, since x is greater than, the arrow goes this way. And since 4 and 1/5 is also, and since x is less than 4 and 1/5 here, the arrow goes the opposite way. So this would be how you would graph it right here. And that's it for the 6.4 lesson of the SATs.